All right, good night, everybody. Glad y'all are here. I'm looking at my phone to start off. That's not good. Good live streaming. Wait, all y'all chatting before? Oh, cool. Yeah. Whew. Among Us. What was a little intense there. My phone wasn't working too well, but well, the streaming didn't work too properly. But I think we got enough good content there. All right, welcome everybody to Sunday Night Live. Share this live with all your Form 5 IT students, students in Form 5 who are doing IT in 2021. And tonight we're doing the algorithm and trace table. Good night, Faith. I am accustomed to you now. You are a regular. Welcome, everybody on the inside. Share the stream in Discord. Or I could give it a share on the IG too. Get them on the inside. Basically, yeah. Xavier. See. Okay. All right, so tonight we're doing the algorithm and trace table. So we're gonna go through the algorithm and trace table, and hopefully next week I will be able to write the actual program code for you. And yeah, so what I'm going to do is I'm going to do a sample SBA program, and the program is supposed to get names or get information from people and create a total of something. And I'm going to do it in pseudocode, and then I'll do a flowchart for it. After I do the flowchart, I will do the trace table. So we will go through the pseudocode and the trace table tonight, and then next week we will convert the algorithm to two different programming languages. Next week we'll do Pascal and C, and then the following week I will do Python and VBA, Visual Basic, for applications. And that should solve those problems. Okay. So I'm going to start by creating a sample SBA question. Well, I'll show you all the syllabus first. So we're gonna go through the syllabus. Don't forget to keep track of the slouchometer. It's very hard to tell if I'm slouching today because I have one black. So it's hard to see the creases, but the slouchometer, I know a little miss. Right. So this is where people make a lot of mistakes because it's worth 15 marks, right? So your word processing and stuff is come to about 20 marks. Your Excel is 20 marks. Database 20 marks. Problem solving is 15 marks. Back in the day, problem solving used to be like 30 marks or something like that. 30, what? 50, 60, 70, 30 or 40 marks, something like that. But now problem solving get watered down to basically real baby stuff, 15 marks. So what we're going to do is we're going to do this, right? So you need to have, for your problem solving, by the way, we did database last week. You could check the link inside this video for the playlist. I didn't put the playlist in. I'll put the playlist in before the live is finished, right? So you must have the start of the algorithm, you must have user-friendly variable names, and you must initialize variables. Then you have to make sure you do request for data, store the data, and do some sort of structures. You have to do selection and loop. So you must have a selection, you must have a loop. They didn't say which type of loop you have to do. So I will show you all some different ways to do it, right? So let's start. So let me go with a simple question I would normally get in a soft drink company wants to determine the most popular soft drink flavor. The choices are banana, red, and orange. Write a program to determine the most popular out of 100 votes. Alright, so that's a very straightforward SBA program that you will get to do. Almost all of them are going to ask you something to determine total cost, or basically you're doing a loop, you're reading the information and you're adding to a total, right? So this one is simple. We want to choose between banana, red, and orange, and we want to determine the most popular out of 100 people. So whenever you're doing the algorithm, you first have to start off with giving it a name, and then you have to identify the variables, and then you have to initialize the variables. So all these are 3 marks here that you must have, and the 3 marks that you get in here will be basically what I'm going to show you now. So algorithm, program to find the best soft drink. Then you have to list the variables that you're going to use. Now, because you may be accustomed writing all the variables at the start, you may be able to put all of them in one time. But a lot of people can't list all the variables one time. So I'll just put the variables for you. We need a C for counter. We need a, damn it, I shouldn't do it in here. I should do it in Notepad++. Okay, that's not. Because the indentation will go too bad there. I do earlier time to now. Alright, so I'll do it in here. Right, so we're going to give it algorithm program to find the best soft drink, and I'll go into it. Right, then I have to declare the variables I'm going to use. I'll put the question on top just for it to see. Because if I don't put the question on top, then you won't be able to know what we're actually trying to solve now. So I'm going to put the question on top, like here. Whoa, that was rough. It's plenty. Okay, cool. All right, so this is the question and this is the code. All right. So the variables I put in, the variables I need to use here is C for counter. Then I'm putting the software I'm using to write the algorithm is Notepad++. It's like Notepad++. Really, I don't have any better way to say it. It's like Notepad on steroids. So basically, you could write Notepad on steroids, right? So we getting C for counter. Then we put in B count, red count, and O count. Right? The reason I'm using those counts is because I want to count the choices that the person makes, right? Banana, red, or orange. Because my goal is to determine the most popular flavor of banana, red, and orange. Or like how some people say orange. Say orange, not orange, because apparently there are other people in the world who watch my videos and they'll be like, wow, his accent is so cool because he says orange instead of orange. Start. Right, so now start. So look at what just happened there. Look at what just happened there. Start of the algorithm, identifying user-friendly variable names and, well, we didn't initialize the variables yet. But basically, start of the algorithm and variable names, you just get 2 marks there for just this. Just kind of like this. That's kind of crazy, right? All right, so then we have to initialize the variables. So basically what I want you to do to initialize the variables is to set them to 0. So b count is equal to 0, r count is equal to 0, and o count is equal to 0. All right, so that now gets us the first 3 marks. And there's the cake marks. This is cake. All you have to do is just start the algorithm, create some variables, and initialize them, and you get 3 marks in your SBA, 3 out of the 15 so far. And you didn't even write any code yet. So now next thing to do in the algorithm is we have to now figure out how we're going to get 100 votes, right? So 100 votes is like this. So I'm going to, in order to do something 100 times, you just have to do a for loop. If you don't know how to do a for loop and you have no clue about it, I have a playlist in the description that goes through the whole of algorithms from start to finish that will help you understand how to do algorithms. And you probably will be like, whoa, somebody should have teach me this. Well, guess what? I can. So I'm using a for loop. So for c is equal to 1 to 100 do. So that's going to loop 100 times, right? That's the whole point of this. This means whatever I have between 4 and end 4, whatever I put in between here will happen 100 times. And my goal is to try to do something 100 times. What do I want to do 100 times? I want to read banana, red, and orange. I want to get the counts. Oh, I forget to put our next variable, vote. Yeah, if you vote, yeah. So I have to set vote to 0 also. Vote to equal 0. Right. So now I'm going to have to tell the user, because whatever is between the 4 and the N4 has to happen how many times? 100 times, kids. Right. So I'm going to print welcome. No. Yeah, welcome to the voting program. And then print again. Please enter 1 for banana, 2 for red, and 3 for orange. And that will do that. Then I want to now ask them for their vote. So I'll read V, which is vote, right? So when I read the vote, now this is where the logic comes in. But before we get to the logic, notice it says here in the syllabus, request for data, aka prompt. The prompt is when I print, please enter, this is the prompt here, line 19. This is me saying, please enter data, or please enter the information, and that will basically be considered a prompt, because I'm prompting the user to put in a value. Then I have storing data, which is reading data. So I read the data into V. So guess how much marks you got in your SBA so far? 1, 2, 3, 4, 5. 5 out of the 15. And you ain't really do anything important yet. So sometimes students get 0 in this part of the SBA. And I kind of wonder why. Because that means you actually wrote nothing. So try not to write nothing now. Try to write something, right? All right, so now we are going to, and we have the for loop. So the for loop is our appropriate looping structure. So there's a for loop, which is here. So we have looping. So now we have 6 marks. No, 5 marks. and then we have to do the selection. So the selection now will be if V is equal to 1, then I want to carry up the count of banana. So I'm going to say B count is equal to B count plus 1. End if. Alright. And then I want to say an next if V equals 2, then I want to say R count is equal to R count plus 1. End if there again. And then my next if V equals 3, O count is equal to O count plus 1. End if. And that is going to solve the problem of carrying up the counts, each count one at a time. So if the vote is 1, I told them 1 for banana, so I'm carrying up B count because 1 is symbolized by, well, represented by banana. If it's 2, I'm carrying up R count because R count is symbolized by red, well, red. And O count is orange count. So once I'm finished with that, I will say, no, not NF, N4. I put the N4 already, did I? Yes, put the N4 already. Alright, N4 is there. Good. So basically, this loop is going to go 100 times according to the question. So the question said, write a program to determine the most popular out of 100 votes. So once we see 100, we know that we have to go 100 times in order for this thing to work. What am I doing 100 times? I'm asking the user, I'm saying, welcome to the voting program. Please enter 1 for banana, 2 for red, 3 for orange. And then I read the vote, because reading the vote means I'm reading it. If the count is that, or that, or that, then I will carry up the count by 1. And then end if N4. Right, now when I'm finished with the 4, I need to print out the winner, right? So print, no, I need to print out the totals. Yeah, print out the totals. So I'll print the totals are print banana, yeah, banana, comma, B count. And then I just do the same thing for all the others. Banana, B count, something, something, something. So banana, then red. Red would be R count. And then orange would be O count. O count. And then stop. And that there is a whole algorithm for SBA that will get you all the marks. Every single mark that you need to get. So watch it from start to finish. Let's see where the marks are coming in. We have start of the algorithm. Do we have a start? Yes, we have a start. I think they're checking all this for the start, but not too sure. So just make sure you put all of that in. And then we have identifying user-friendly variable names. User-friendly, C stands for count, that's user-friendly. B stands for banana count. R stands for red count. O stands for O count. That is very user-friendly there. What I mean by user-friendly variable names is that some students will just put A, B, C, D, E. That not really gonna make sense, so don't do that. Then this is not Pascal, you know, this is not Pascal yet. I'm not doing any, this is not actually code yet. This is just an algorithm. This is just the steps to do it. We can actually use we ain't actually doing the actual code yet. Next week I'll do Pascal and C. So yes, having this one. Hey, Christopher, I'm glad you're here. Y'all, this guy in the chat here, Christopher Williams, he knows about this SBA more than me. And going to interview him next year, January. Well, I didn't tell him yet, but I'm going to interview him next year, January, to get the ins and outs on how to do the SBA. When things start to get hot now, when students start to actually care, other than the 16 people that are inside the live right now, right? But yeah, so he know everything about his SBA because he's actually marked them. And as soon as next year hits and exam season starts to get hot, I'm bringing him on the live, and we will interview him and ask him all the questions that you want to ask about TXC. But it wouldn't make sense doing that now. We don't have enough audience. So when the word start and stop, I don't know, you just get a mark for when start and stop. But why do I tell you why? Put in start and stop. Free marks. Identifying user-friendly variable names, free marks. Initializing variables basically means set everything to 0. So once you set everything to 0, you have initialize it, meaning you put an initial value inside of it, right? Then we need to put some logic inside. Ask about the Baba once a month. So as look staying for the first 2 weeks, and then the next 2 weeks I was being guerrilla mode. But anyhow, I find these slouchometers and tell them if I'm slouching, you know. But anyhow, it's cool. Alright, so request for data. Storing data or reading data and having loops. Right, so let's look for the storing data mark. Did we store data? Yes, we read V. Did we prompt? Yes, we got the prompt, because prompt means ask the user to put something in. And then if V is equal, right, so if V is equal to 1, if V is equal to 2, right, good. So this is the logic here. This is the for loop mark. And this is the if mark. Now this is a real simple algorithm. I know some of y'all have some teachers that's still making you do arrays. I am not that guy. If your teacher is making you do arrays still, tell it, respectfully, let your teacher know, sir or miss, we are under the 2020 syllabus, therefore arrays are not required anymore, so we do not need to input arrays into our program. We could just write a simple loop. However that goes for you, that's your business. I just letting you know, I'm not going to be teaching you to when I'm doing ComSci lives, I'll teach arrays, but not for IT anymore, because then I'll confuse too much students, because then they'll think that they need to do arrays still. So I ain't going through that, right? So we have the loop in place, right? So now what will happen is that this is going to check to see if V is equal to 1, add it. If V is equal to 2, add it. If V is equal to 3. Some of you all may be accustomed using else if. So if, and then you have a else, then a next if, then else, and a next if. I just find sometimes that's confused children. So I just have distinct ifs. If it's 1, add up the count for banana count. If it's 2, add up the count for red count. And if it's 3, add the count up for orange count. You could do that, and I'm positive that you'll get the marks, because what the syllabus is looking for is selection. It didn't say that the selection must be if else. It just said that you have to select if. That's the test. And then printing out at the end. Does it have any marks for printing out things at the end? No, there's no mark for printing out things at the end. But I mean, you should print things out at the end. It would kind of make sense for you to do that. Okay, all right. So that's the algorithm. Now let's convert this to a flowchart. Just in case your teacher requires you to do a flowchart instead of writing an algorithm, that is totally legal also. So I have to show you how to do a flowchart. Oh, that's stuff from last night's live. Yeah. All right, so let's see if we could get this flowchart in a gear there. All right, so the same marks that you look for in an algorithm, the same marks you look for in a flowchart. Now, normally, I let my students just write an algorithm, because in order to do a flowchart, you need to have the algorithm before. So if you write the algorithm and then you decide to draw a flowchart, it's kind of like double work. So it's not necessary, but some teachers will allow you to do a flowchart, want you to do a flowchart and not have an algorithm. So we can figure it out as you go along. So we're going to have in our flowchart, we're going to usually start with the word start. So we'll have start, and that is in our oval. But the thing is, I don't see any distinct marks telling you what to look for in the flowchart. So I don't know what will happen if you use the wrong symbols in your flowchart. if you use the wrong symbols in your flowchart, I gather that you will just lose the marks because you can't put the start of algorithm in a rectangle. I don't know, Christopher could probably answer that for me in the chat if you know. What happens if somebody puts start in a rectangle? Is it that they get a mark for start or just wrong? like no, you wrong. You so wrong. Don't even bother to give you a mark even though you have the word start, because that's kind of awkward to me. But we could probably clear that up when we have our interview. Alright, so you're saying the correct shape has to be there, which I suspected because it'll be kind of weird for you not to have the correct shape. Which is why I don't really like force children to do flowcharts, because unless it's a, you know, unless you have a class where they, you know, they need to be challenged and stuff, yeah. Right, good. Thank you very much, Christopher. Greatly appreciated. Wait, you didn't get to play the Among Us today? Alright. Alright, what's up me this week? And I'll get a little trial run on Among Us, and then you'll be able to come in here. My dream is to have a Among Us Teachers Edition, but I don't have enough teachers who will play now. I'll get the other teachers from like Jamaica and the teachers from Barbados or something to play Among Us and let them stream it. But it'll be kind of cool. So I might try to rope in. Alright, so then variables now. So we need to create the variables and we need to initialize them. So to initialize all the variables, you need a rectangle. Hey, look, Charlene, Bell, George, nice to have you on the inside. So you're going to put B count equals 0. Only message me on Instagram and we could sort the thing out. R count. Imagine how more IT teachers and students on my live. That's kind of quick. Kind of weird. But that's how the thing does go, because by next year, you'll see like 100 and something people on live and they're asking questions about the exact same thing they're doing right now. But however, teachers, students, it don't matter. We just want to make IT big in the Caribbean and create industries and jobs and all that good stuff. Okay, right. So the reason I put this in a rectangle is because this is initializing all the variables. So this is lines. I'll put the lines next to it so that you could see. So you can see which lines I'm representing in the code. So this is line 12 to 15. Oh, that's a real bad color to use it like. This is line 12 to 15. This is line 11. Right. All right, next one is now we have to simulate the for loop. Right, the problem with simulating our for loop in our flowchart is that you can't have a for loop in a flowchart because you can't put. What students tend to do is they try to put a diamond and put the diamond to say 4C is equal to 1, 2. Oh, that was a boop there. I didn't mean to do that. I'm hungry. Let me leave it as that, right? I'm hungry. 1 to 100. This you cannot do because the for loop will be like, yo, that not working out too well. Oh, Fitz, you catch me. Sorry. I started to get comfortable there. All it was like kind of, all it was letting me slack off. Alright, so you can't represent a for loop. So in order to represent a for loop, you have to change it to a while. So let's pause on the flowchart there and go back to change this thing to a while. Alright, if I have to change this to a while, let's take the whole code and create a new one, right? Okay. So what we're doing is we have to erase this for loop part and change it to a while loop, right? Now to change something to a while loop, you have to put the word while. But we have to say while C is less than or equal to 100, do. But the problem with this is that we don't have anything that will control the loop. So we have to control the loop somehow. In order to control the loop, you'll have to initialize the C and set that equal to 0. No, set that equal to 1, sorry. So that will start at 1. And that way, it will know where to start. So we'll check to see while C is less than or equal to 100. As I said before, if you all don't understand loops and it's not making any sense to you at all, the playlist in the description will send you to about 5 videos where I explain loops from start to finish, from sequential, algorithm from start to finish, from sequential all the way up to trace tables. So if you don't understand, well then let's kind of follow and you could watch the playlist after. So I set the counter to 1, that means the counter will start at 1. And it's going to try to work its way up to 100, but in order for it to work its way up to 100, I have to put the count in. So I have to put C is equal to C plus 1. That will make sure that the count keeps going up 1 by 1 each time. And then I could end the while. So here's the 3 parts for a while loop to work. You need to have the C starting at whatever number. Then you need to have the actual condition to say where you want to go up to. And then you need to have the counter inside the while loop for it to work. There are 3 parts to convert a for loop to a while loop. So this is the for loop here. The for loop smart enough to figure out, okay, I'm just going to go from 1 to 100. No issues there. Easy, easy. The for loop smart, it went to college, has a degree. Even though having a degree doesn't mean that you're smart these days, but long story short, the for loop is smart. The while loop is not smart. The while loop could only check one thing. So we have to say where to start, where you're trying to go to, and how much to count by. Always remember that. You probably might see a question with that sometime in your life too. Where to start, how much you want to go up to, and then how much you're going to go up by. Right? If your C starts at 0 faith, then you will say less than 100. So if you start C at 0, then you will just say less than 100 because you will be going from 0 to 99. And 0 to 99 is actually 100 numbers because 0 is a number. But for ease of understanding, for most students, I will always just start C at 1 and go to 100. The problem is, like some students will grasp the 0 to 99 as 100, but then some students don't grasp it. So there's grasp counting from 1 to 100, right? So let's see. Oh, look, you grasp it there. Faith, we don't say "oh" in this chat. You have to send the scholar hat. Yeah, let's send the scholar hat. If you don't send the scholar hat, that doesn't make me feel like you understand something. All right, good. So I converted it to a while loop. So I'm going to use the while loop version in the flowchart. As I said before, a flowchart is not necessary for you to do, but sometimes teachers require you to do the flowchart because, I don't know, it might be easier to mark sometimes, or you have less, actually I find a flowchart harder to mark, but. So if I convert this to a flowchart, then I'm going to go with, in a flowchart, what you're really trying to do is ask a question. So you're going to say C, why did I put that in black? I put it in red. All right, so you're going to say C less than or equal to 100. That means usually a flowchart is a question, so it's a question mark to be like, okay, is C less than or equal to 100? And the options are always going to be yes or no. So if the answer is no, more than likely you're going to do the last thing of your program. So always kind of remember, once the loop is finished, put the no going down that way because it'll make your life a little easier. If the answer is yes, however, you put the yes going to the right-hand side because you'll have more space on the right-hand side to work with. Well, that's just how I do it. So you have the yes, and then the yes is going to now do the things that you said to do in the program, which will be print welcome, blah blah, and then print please enter. Of course, when you have space, you'll put in, right? Please enter stuff. I'm going to put the line number so that you all know this is line 19 and this is line 19 and 20. All right. This here is line 18. Anything that you see in green, that's just the line number to match with the algorithm. So you look on the left-hand side and you see what they did on the right-hand side, right? Okay, good. So now that we've gone through the yes and no, we now have, or don't forget to put the arrowheads. If you don't have the arrowheads, I think you'll lose marks in our flowchart, but long story short, I ain't too sure. What next? Right, good. So after that, we have to now read V. So I'm going to put the parallelogram, because a parallelogram is what you used to read. If you didn't know that, playlist for you. And then after I read the V, I'm going to have to now make a set of choices. Now the choices are going to have to be represented by diamonds. So the first diamond is going to be if V is equal to 1, question mark. If the answer is yes, what are we going to put? We're going to put a rectangle, because the rectangle is representative of a process. And whenever you have an equal sign, just tell yourself you're doing a process. Processes are always equal signs. So V is equal to, no, B count is equal to B count plus 1, my bad. B count is equal to B count plus 1. That's not very clear. I need to make that clear. Plus 1. Right. And then if the answer is no, then I'll just kind of join back here, because obviously it wasn't equal to 1. Then I'm going to have a next diamond, which is if V is equal to 2. If V is equal to 2, yes. Then I'm going to say R count is equal to R count plus 1. And then if that doesn't work out, then I'll have the no, and that's going to match back to there. Then I have a next diamond, which is my third choice in this particular program. V is equal to 3, right? That's a question mark, by the way. If the answer is yes, then I'm going to say, and although don't beat up too much about my Crapofoot handwriting, because my handwriting is horrendous. But what are you gonna do, boy? Too late to fix that now. O count is equal to O count plus 1. And then this one will be no. Right, good. So after all that is done, this is where it's making money. This is where it's making money. So I have represented line 22. Damn, I make a kind of bunching of these spaces. I've represented line 22, line 24. This is line 25. This one here is line 28. And this is line 29. This is line 32. And this is line 33, right? So I've represented everything up to line 33. But if you look at line 34 now, nothing happens. But you see this line 36 here? This one is real important. This is what's make the loop loop. So what I want to do is I want to find a way to come back up here and check to see if the actual if the number is actually less than 1 or not. Because remember, the C counting all the way up. So I'm trying to find a way to get on top here. I'm putting this in red because you'll need to see it in red. What has to happen is, no red, I'm leaning forward with great anticipation and excitement. What happens is this has to loop up all the way here and check to see if the count is less than 100. But I have to represent line 36 somewhere in order for it to know that the count went up. Or else the count will never know that it went up. So what I have to do is I have to put C is equal to C plus 1 here. And that represents the actual loop taking place. Then, once that is done, I now reach to line 40 and 41 and 40 to 43. Because the loop is finished because of the word n while on line 37, I done. So I've represented line 36 here. Good. The next thing I have to represent is what needs to take place if the loop is finished, which is all the prints. And the prints are represented in parallelograms. So I'll put one big parallelogram and I'll print stuff. Print totals, print the next one, print the next one, and print the next one. And then you'll see line 44 says stop. So what I have here is line 40, 41, 42, and 43. And then stop is line 44. And that there is the flowchart for this algorithm. Now, as you can see, it took a little longer to do that than to actually write the algorithm. So if you understand how to do the algorithm, cool, no problem. But if you don't understand how to do the algorithm and you just get thrown straight into a flowchart, you're most likely going to have to do the algorithm first before you could actually do the flowchart. So if your teacher gives you the opportunity to do the algorithm or the flowchart, I suggest you just do the algorithm, because that's just to type out this code here, logic. Because to get the flowchart done, you have to do the algorithm anyhow. So let me just zoom in on it so you can see it a little bigger. It starts here, which is start. We set all the counts to 0, so this will be the mark for the initialization. It had to be in a rectangle, of course. First thing we're going to ask is if the C is less than, I didn't set the C to 0 here. I had to put the C is equal to 0 inside here, right there. So then the first question we're going to ask is the C less than 100? And if the answer is yes, then I have to print, please enter the vote. I read the vote, which is a rectangle, a parallelogram. After I read the parallelogram, I have all my ifs to check, so I'm checking to see if the vote is equal to 1, carry up the B count by 1. If the vote is equal to 2, carry up the R count by 2. If the vote is equal to 3, carry up the orange count by 3. And when that whole loop is finished now, I have to add 1 to count, because now I'm checking to see if count actually reached 100. And if it doesn't reach 100, then if it does reach 100, sorry, then I print out all the totals and then I stop. Faith, why are you asking if the flowchart actually works? I really don't understand what you mean. Like, what does it mean for a flowchart to work? It's kind of awkward there. I'm not making sense now. But rephrase that question, rephrase that thing. All right, so let's go into the trace table now. So I could copy the algorithm from here. No, I'll just put the trace table on the side of it. All right, so this is what the trace table will look like, right? So a trace table is you tracing every variable. So let's now, before I pause, before I go on, let's check to see what we just did. We did flowchart or pseudocode. So I'll show you the pseudocode and I'll show you the flowchart. Same set of marks apply. You just have to show the selection in the flowchart by having the diamonds. I don't know if it's just one diamond alone you need in the flowchart that works, or you need all the diamonds to work. Christopher, you can tell me that in 1 year there. I just hope all the diamonds are working. The looping, you have to show that the loop works if it's a while loop or a for loop, right? So when I'm reading data, those things must be in parallelograms. Wow, just one diamond required, boy? Way. Okay. There I was thinking that, IT was, challenging again. Okay. All right, so after we do that now, we're going to go to the trace table now, because we got the 6 marks here. Whether you did the algorithm or whether you did the flowchart, doesn't matter. That's 6 marks that you're working for there, right? Oh, Pete, that's what you meant. If the flowchart has to work, well, yeah, the flowchart has to have the correct symbols. If the flowchart doesn't have the correct symbols, you won't get the mark. You'll get partial marks. Right. Understand what you're saying. So that to demonstrate the skill. So Faith, if you do your flowchart and you have one of the ifs working properly, you'll get correct, because you show that you know how to do it. And if you have the loop working properly, you'll get the marks. Whether it's 2 loops, 4 loops, 5 loops, 10 loops, however, doesn't matter. Once you prove that you know how to do it at least once, your teacher has to give you the mark. Yeah. Okay. Oh, that's some good knowledge there. Some good knowledge. All right, so let's go on to the trace table. So for the trace table, I'm going to have the algorithm on the left-hand side, and I'm going to have the code on the right-hand side. How much programs I did so far? All right, cool. Okay, so we're using this. So to do a trace table, you have to first represent all of the variables that are in your program. So let's start first by making sure we represent all of them. So all it basically doing is you're going to look at your variable counts, your variables. So you have a C, you have a B count. No, you have a V, sorry, you have a V. Then you have a B count. Then you have a R count. Then you have a O count. Right? So all of those things are counts. I'm trying to make sure the table fits. Oh, I have an extra column there for no reason. All right, let me take care of that column. All right, good. So we have the C. C stands for count, V is for vote, B count, R count, and O count. All right. Now what they have introduced into the, well, not that you all care because you all didn't do CSEC before this, but what they have introduced into the syllabus is now that your test cases now have to show errors in the trace table. I mean, you used to have to put errors before in the trace table, but it was kind of unclear if you had to, how much errors you had to show. But the goal is variables must be identified in the trace table. Did we identify the variables? Yes, we did, because they are the headings here. C, V, B count, R count, and O count. Those are the things that are on top. No issues there. Then you have appropriate test data. So appropriate test data means you have to now go through the actual numbers that the people are going to put in. So let's say a loop has to run, okay, I put this loop to run 100 times. That's not very smart. I should have put it for 10 times. Let me change that. So let me put for 10 votes, because if it's 100 votes, then your trace table is going to be super huge, and, well, you don't want that kind of drama in your life. That's a whole 2 documents something you have to do. All right, so basically the count is going to go from 1 to 2 to 3 to 4 to 5 all by itself, right? So I don't really have to there's an easy way to do this, you know. 6, 7, 8, 9, and 10. All right, so 10 times this loop is going to happen, right? Because we know we have a for loop and we know it's going to go 10 times. Don't mind I do it as a while loop also here. Same concept will happen. C will be 1, and then C will end up reaching to 10, right? If you change the loop. While loop or for loop, both of them going to do the same thing. All right, so I have to now represent 2 different things. I have to represent the test data, meaning what test data would an employee put in? All right, what test data would an employee put in? And I must show that the changes in values are correctly demonstrated. 1 mark for, wait, 2, 3, 4, right here. No, this is 4 marks, or 2 marks for the correctly demonstration, but you must have an error in manipulating the trace table. You must have an error. No, some errors, sorry. You must have some errors. So within the 10 things that inputs that we get from the user, we must put in some errors. So I say like 2 or 3 errors would be good enough, right? So let's see if we can simulate that. So what is going to happen? I'll do this trace table again over when I actually do the program code next week, right? Next week when I do the program code, we will check the actual inputs that we put in and make sure that they give the correct numbers, right? The trace table is supposed to be a test. So if the person puts in their vote as 1, the B count is supposed to go up by 1. So it should show you 1. The R count will be 0, the O count will be 0, because those were all initialized to 0 at the start. Then, let's say somebody puts in their vote as 2. It's smart to prove the correct things first and then prove the wrong things after. If you want to put some correct and then some wrong in between, you could do that, no problem. But remember, it's a human being examining it, and the human being is basically, you're kind of making it easy for the examiner to mark it, right? So if the vote is 2, B count stays at 1. The reason it stays at 1 is because it was 1 from before, because we got our 1 here. So we leave it as 1. R count will go up to 1. Orange count will stay at 0. And let's say the third vote comes in now, the person votes for 1 again. B count will go up to 2. R count stays at 1, and orange count stays at 0. So that is a correct representation of the variables changing. So you could do this up to 5, 6, 7 times, but I recommend you have at least 3 errors, right? Because the errors need to be glaring now. So let's say the person puts vote 1, 2, 1, and then the next vote is a vote 3. B count will stay at 2 because it never changed because we only got the vote once there. R count will stay at 1 because it never changed because our vote was 3, and now O count will go up to 1. Then let's say the person puts in a 1, we will get the B count going up to 3, 1, 1 because those never changed. And now, okay, now we'll put in an error now, right? So I'm going to put in an error. Let's say the person puts in the number 4. Because our program has no way to account for the number 4, the loop will just run and none of these ifs will ever kick in. This if will never happen, this if will never happen, this if will never happen because the person puts in the number 4. So because the person puts in the number 4, we'll just leave the numbers as is. No issues there. Some of y'all in your SBA, you're going to be required to put in error messages, and our error message is totally unnecessary because you only need one if, and our error message is basically an if to check to see if the thing was put in properly. But if that happens, you will you'll probably have a column for error. But more than likely, I doubt you will see that because I don't know. There's some wicked teachers, but then they have wicked teachers. So yeah. So what I was going to say. All right, cool. Oh, okay. All right. I think I misinterpreted this wrong. Changes in values correctly demonstrated is 2 marks. Meaning you do your trace table properly with no mistakes, you'll get 2 marks. If you have mistakes in your trace table, you'll only get 1 mark. I was thinking that you need to demonstrate errors in your trace table. Wait, I just confirming something here. So basically, put in. So it seems like you had to put in correct data only. Ah, okay. All right. I probably got that idea from ComSci. Okay, my bad. Okay, so don't put in wrong data, only put in correct data. That way, it will work. Whew. I guess save the yes. Right, yeah. All right, so we only put in incorrect data. I misinterpreted what they said. That's so odd, though. I don't know. All right, so if I get 1 here, the 4 will go up, so that 4 will stay. Then I put the 2. Yeah, will go up to 2. Right, and that will stay at 1. Then if we get 3, that will stay at 4. R count will stay at 2, and O count will go up to 2. We get our 1, this will change to 5, that will stay at 2, that will stay at 2. We get 2, that will stay at 5. R count will will go up to 3, and then O count will stay to 2. Right, good. So this is a trace table that literally shows correct inputs put in by the user and you showing the correct numbers going up at the time. So an easy way to check it is you can check back the votes or whatever that I got. So if I got vote 1, 2, 3, 4, 5, in the end I'm supposed to have 5 here. I got 2, 1, 2, 3 times. I'm supposed to have 3 there. And for O count I had 3 twice, so that's 2. So that is a correct trace table that has proven that it is correct because the correct way to interpret this is changes in values must be correctly demonstrated, meaning that you must put in correct values only, and the trace table will correct it. And if you make errors in adding, because I don't know, you probably made errors in adding, you will all right, that makes sense now. Right, so that's what we had so far. Right, so let me just recap before I move on, and you all can ask questions in the chat if you want to. We have the algorithm which I did at the start. This algorithm here is trying to find the more popular of three soft drink flavors. Almost all SBAs will have some sort of getting a loop of certain things and counting them or adding them or some kind of thing like that. Keeping track of it or see who got the most votes or something like that, right? That's the sample SBA one, right? So you check that, see if it's correct or not, and the algorithm is there. If you have to do a flowchart, then you could do the flowchart, which is what I did here. Like that. All right, so this is the flowchart for it. And then after that, the next thing you have to do now is a trace table. And the trace table, though it's worded kind of weirdly, you must show that you correctly change the values. So you put in the actual numbers of 1 to whatever. Because you said in your prompt, put 1, 2, or 3. Person puts in 1, 2, or 3. And all they're doing is carrying up the counts appropriately. No issues there. And that should be it for those marks. So far we have gotten 10 out of the 15 marks for our algorithm. It's kind of weird though that the actual working program is only 5 marks. Actually no, the working program is just 1 mark. 3 marks for writing the code. So if you suck at writing code, then you could literally come through this this part here with 11 out of 15 marks if you really can't even write the code. But I don't know, some teachers may focus a lot on the code when really and truly we should focus a lot on the trace table and your algorithm. If your algorithm in a mess and your trace table in a mess, that's 10 marks that you will lose. And you really don't want to lose those 10 marks. All right, so having the working program, we'll get to that next week. All right, so as I said, next week we're doing it in Pascal. This exact same program here, exact same code. I'm going to convert it to Pascal and C. That's next week. The following week, I'm converting it to Python and Visual Basic. Keep in mind, I have no idea how to code in Visual Basic, so I just go and figure it out. But if I could figure it out in a week, you could figure it out also, right? Because last time I looked at Visual Basic applications for that they was doing Excel, I was like, what really going on inside here? But it should be straightforward because they expect you all to be able to do it. So if you're doing Pascal, next week for you. If you're doing C, next week for you. If you're doing Python or Visual Basic, I think those are the 4 programming languages that are accepted. There may be more, but I can't remember. I can't remember exactly. See if I can find it. Python inside here. Nope, no Python. Basically, you could use any programming language I want, so they don't really have any breakdown. And then documentation. Documentation, I'll show you all that after. Java is accepted here. Pascal, Python, C, VBA. Yeah. Nah, I doubt anybody, and I doubt you're not doing JavaScript in CSEC. No. Tyrone, you're kinda missing the bus here. This is for CSEC students. This is for students who are doing CSEC examinations. You can't submit an SBA in JavaScript. Actually, you probably could. No, you can't. I don't know. But I just doing those 4 basic programs. 4 basic programming languages because those are the 4 that most students would have approached me with over the year. Well, like last year. That's the 4 programming languages I saw. And like 90% of it is Pascal. I was doing that first. Some of it was C. Some people were Python. And the one person that came by me with VBA, I just kind of felt sad for that person. I was like, wait. And the teacher didn't even teach you how to do the VBA. They tell you Google it. That's not cool though. That's not cool. So that is it for today, guys. So the algorithm and trace table, this is where most people always fall down. Share that with your human being friends in school, and you could go on to your SBA properly now. And when you're supposed to submit your program, you should be able to use this as a guide to figure it out. All right, so don't forget to follow me on Instagram. Let me know what you're going, what's up. I'm going to put the playlists for the problem solving and algorithms for those of you who don't know how to do it in the description of the video. And I will see you all next week. And for all the people that have been messaging me on Instagram asking me to do their SBA for them, no, I cannot do your SBA for you. But there is a live every Sunday night, which is now, that you should be able to, you know, come in and ask questions. But as expect, like most students, they don't like to do the hard work. They like somebody to do it for them. So I don't know. Algorithms playlist. That's the algorithms playlist here. Ren one all you could get the playlist for the SBA. Faith, I was supposed to put the link for the SBA PDF. Alright, I think I have that. I think I have that in Drive. I could put that for you one time because I keep forgetting to do that too. SBA. CSEC, Information Technology, Syllabus with Specimen paper. Yep, found it. Did I not share this? Share. Copy link. Alright, I'll put in that link in this stream too. A direct link to the SBA. Syllabus. I can't type properly. Syllabus and Specimen paper with SBA. Right, that link is there. Look at me linking. Anybody get the SBA playlist? All right, yeah, cool. Thank you very much, Ren. Much appreciated. I'll dance at your wedding if you invite me. All right, all the shit is in the description there. Check in the description and see if you see them. Check now. Why do I still have on headphones? I asking myself. I acting like I still play Among Us, yes? Yeah. What you seen there? No. Alright, so every single SBA video will be inside that playlist. Including the specimen paper SBA that I did way back when Moses was a boy. Yeah, all that there. Alright, great. Alright, thank you very much for your time, guys. I went like 3 minutes over. So have a good week. I will see you all next week when we're doing the actual code. And then I don't know, by December, I'll probably start to take random questions from people who have questions about different things in the SBA and see. Gio, what kind of shipping mods time to mod out? Yeah, alright, follow on Instagram if you want IT classes. You can check me too. Just message me wherever, or you could message on the website.